Good afternoon, distinguished colleagues and guests. It's May 20th, 2021, 4 p.m. and 2 p.m. Moscow time. We're beginning the panel session for the defense of the thesis by Aleksandra Petrunina. This is submitted for the academic degree of the candidate of sciences in chemistry. The specialization is 020002, analytical chemistry. The topic of the thesis is chromatomembrane gas extraction in the process of concentration of volatile organic compounds from aqueous solutions and generation of standard gas mixtures. Under the order issued by Alexander Gnotov, the Academic Secretary of St. Petersburg State University, as of February 25th, 2021, number 1362/1. I, Lyudmila Kartsova, Doctor of Sciences in Chemistry, Professor of the St. Petersburg State University Organic Chemistry Department, was appointed the chairperson of this dissertation board. The order also approved the candidacies of the members of the board. Let me introduce them. Igor Zinkevich, Doctor of Sciences in Chemistry, Professor of the St. Petersburg State University Organic Chemistry Department. Vladimir Povarov, a Doctor of Sciences in Chemistry, leading researcher at the St. Petersburg Mining University. The following members of the board are working remotely. Grigory Tsizin, Doctor of Sciences in Chemistry, leading researcher at the Analytical Chemistry Department of the Lomonosov Moscow State University. Grigory, do you hear us and see us? Do you? Grigory, do you hear us? Please turn on the microphone. Grigory Ilyich, turn your microphone on if you hear us. I announced the first technical break due to the loss of connection.
Алло. Нет, я слышу только английский текст. Русские выступления и председателя я не слышу.
I therefore close the first technical break and we continue our session. So, Valery Sidorov, Doctor of Sciences in Chemistry, Professor of the Białystok University of Technology, Poland, is absent. And our candidate for the degree, Aleksandra Petrunina. And we also have the thesis supervisor, Oleg Rodinkov, Doctor of Sciences in Chemistry, Professor of the Analytical Chemistry Department of the St. Petersburg State University. Dear colleagues, in order to improve the quality of our connection, dear colleagues, those who are working in the remote mode, don't forget to turn off your microphones and turn them on when I give you the floor. And I would also like to inform you that the panel session of the Dissertation Board is being recorded and broadcast on the St. Petersburg State University website, and it is also interpreted from Russian into English, or vice versa. Currently, we have an email address posted on the page with live broadcast of the board session, and all listeners can submit their questions to Ms. Petrunina online. The questions regarding the thesis or scientific discussion. These questions will be forwarded to me by our technical service, and I'll read them out during the discussion. Questions must be related to the speech, the presentation, and the content of the thesis. And do not forget to give your name and position if you submit a question. Questions that have nothing to do with the scientific discussion or the text of the dissertation will not be voiced. Under the order on the procedure of granting academic degrees at St. Petersburg State University, approved by local normative acts, the session of the Dissertation Board is valid, providing 2/3 of the appointed board members are present. The total number should not be fewer than 4 people. The Dissertation Board consists of 5 people. 4 are with us today, including 1 member of the board who is working remotely. We have a multimedia connection with all the members of the board, as well as with our candidate for the degree, therefore we have a quorum. Our session should not last more than 2 hours, and the agenda is as follows. First comes the chairman's presentation about the documents submitted by the candidate for the degree and their conformity with the requirements. Then chairman's replies to questions, if any. Then we're going to listen to the candidate's presentation, providing an overview and findings of the research. 15 minutes for that. Then questions to the candidate regarding the presentation, no more than 2 minutes per question. Fourth, the candidate's replies to the questions, 5 minutes for all. Then, the reports on the thesis. The board members will be taking the floor in turns to provide their reviews and questions and offers. 10 minutes each. Then the chairman's report on the thesis, also 10 minutes for that. Then the candidate's comments about the reports on the thesis and replies to the questions. Next comes the open discussion. Anyone present at the defense may state their position or ask questions. 2 minutes per question. And I kindly ask you to fill in the registration form and introduce yourself before I give you the floor. Then the chairman will ask the questions submitted during the broadcast via our website. The candidate's replies to the questions, 2 minutes per question. Then the presentation of the candidate's thesis supervisor, 3 minutes for that. Then comes a 5-minute discussion before the open balloting on conferring or non-conferring the academic degree. The discussion of the results of the defense is not broadcast. Next comes open balloting, vote counting, and recording of the results in the protocol. Then we are going to make a decision on whether to confer the academic degree or not. And finally, we are going to listen to the candidate's closing speech, and we'll give 2 minutes for that. Distinguished colleagues, any questions or comments on our agenda? If there are no questions, let us proceed. But before we do that, I kindly ask you to switch off the sound on your mobile phones. Thank you. So, let me start. The thesis by Aleksandra Petrunina for the academic degree of the candidate of sciences in chemistry, specialization 020002, analytical chemistry, is titled Chromatomembrane gas extraction in the processes of concentration of volatile organic compounds from aqueous solutions and generation of standard gas mixtures. The thesis was approved for the defense by the order of the Academic Secretary of St. Petersburg State University, issued February 9th, 2021, number 1000/1. Aleksandra Petrunina has prepared her dissertation at St. Petersburg State University, and Oleg Rodenkov, Doctor of Sciences in Chemistry, Professor of the Analytical Chemistry Department of St. Petersburg State University, is the thesis supervisor. 4 published works describe the research findings. There are 2 papers published in peer-reviewed journals recommended by the Ministry of Education and Science, and 1 paper published in journals indexed in Web of Science and Scopus. The candidate has submitted the full set of documents to the academic secretary. The above-mentioned documents comply with Item 12 of Section 3 of the Order on the Procedure of Granting Academic Degrees at St. Petersburg State University. As far as I'm informed, all the documents submitted meet the requirements and are found in the certification file of the candidate for the degree, and the curator of the defense, member of the Dissertation Board Support Department, has all the copies. And before I give the floor to our candidate for the degree, I would like to ask the members of the board if there are any general questions to the candidate for the degree. Is there a need to read out and to consider the whole list of documents submitted by the candidate for the degree? Okay, I get it. No questions. Okay, we give the floor to Aleksandra Petrunina for the short report on her thesis. The distinguished colleagues, the topic of my speech is chromatomembrane gas extraction in processes of concentration of volatile organic compounds from aqueous solutions and generation of standard gas mixtures. The development of highly efficient methods of definition of VOC in aqueous objects is the relevant problem of contemporary analytical chemistry. The solution of such problems is possible with the application of chromatomembrane gas extraction, and that's one of the options of mass exchange process, which was offered by Professor Moskvin. Thus, the work was aimed at achieving 2 interdependent goals: the detection of regularities, analytical and metrological opportunities of chromatomembrane gas extraction, applied to the definition of microconcentrations of VOCs in aqueous solutions and the generation of standard gas mixtures for air analysis. On this slide, you see the provisions brought for the defense. In the first works on chromatomembrane gas extraction, it was demonstrated that it is more efficient than traditional similar processes. However, the analytical opportunities to combine this process with PATP were poorly studied. And this process is known as Persian trap pre-concentration. The chromatomembrane gas extraction process is carried out at the biporous matrix with the use of polytetrafluoroethylene, which has two types of pores, and there are macropores that represent space between granules of fluoroplast. And here's the movement of liquid phase. And the granules contain pores, smaller pores, micropores, through which gas extraagent goes through. And the major parameter that defines the opportunity of chromatomembrane gas extraction is capillary pressure. The chosen conditions of chromatomembrane gas extraction, for example, temperature of the process, configuration, and porous structure of the chromatomembrane matrix, had no experimental validation. And the optimal size of particles define the passage flows. And from this data, we see that when the particles increase, we see the rise of flow of extragent through the cell. And choosing the height of matrix, we should take into account that it should provide for equilibrium between the phases. Thus, we chosen the following size of the cell that met the necessary requirements. The practical value is represented by three transfer schemes. When we carry out chromatomembrane gas extraction, that's direct flow, counterflow, and double dimension, during which the phases move perpendicularly. And a natural parameter that defines the choice of the scheme of chromatomembrane gas extraction is the Q concentration coefficient. And in full extraction of analytes at a thermal desorption stage, the Q concentration is proportional to the concentration of analyte in gas phase. And when we carry out the condition when coefficient of distribution is much higher, much lower than the consumption, and we have equilibrium saturation or full extraction, the scheme of chromatomembrane gas extraction does not influence the concentration of analytes in the gas phase. Therefore, we would rather use direct flow scheme that provides higher flows of extragent gas. The optimal temperature of gas extraction is defined by two factors: the coefficient of distribution of analyte and the content of water vapor in extragent gas. The more polar the analyte is, the higher the K coefficient, the lower the temperature of gas extraction should be due to losses of analyte in the formed condensate. These losses can be assessed a priori using the equation number 2. If gas extraction is carried out at 60 degrees centigrade and concentration of water vapor is carried out at 25 degrees centigrade with an error of 3% and losses of analyte loss, we can neglect K that is smaller than 1000. The application of temperatures higher than 65 degrees centigrade is irrational due to the high content of water vapor in extragent gas. And on the slide you see the chromatomembrane option of PATP scheme. The flow of water phase goes to chromatomembrane layer and goes through the second screen to discharge along with liquid phase. We see the flow of extragent to the cell, and this flow with extracted analytes is submitted to a metal tube that represents a condensator of excessive liquid. Then the flow goes to sorption column, And after that, after a certain passage of volume, we carried out one-step or two-step thermal desorption. The first scheme is based on two-step thermal desorption, and the use of polymer sorbents is the universal one and has rather low detection margin, but it's not an express one. The second scheme is an express one, and it is used well for VOCs, and it's based on the use of surface layered sorbents and single-step thermal desorption. When we carry out two-stage thermal desorption, the concentration of analytes was carried out in a glass tube that was filled with parabac Q. Then sorption column was heated up until 190 degrees Celsius, and analytes in the flow of extraction gas were shifted to the trap, in which we had a smaller volume of the sorbent. It was found at 20 degrees Celsius, and this temperature was supported by a Peltier element. Then we heated up sorption trap, and analytes in the flow of extraction gas shifted to the chromatographer. The chief characteristics of the device scheme are given here in the table. This scheme creates prerequisites for the analysis of the majority of VOCs in aqueous solutions that are lower than maximum permissible concentration. It allows to track concentrations. The differences between the introduced concentrations and the results of analysis using the standard method are quite insignificant, and this means that the scheme is correct. And the choice of the most efficient sorption material was carried out. We carried out retention tests on different sorbents, and we also tested single-step thermal desorption. And as we see from the results, the most efficient sorbent for the concentration of VOCs is activated carbon on furfural. The application of carbon sorbents compared to polymer sorbents allows to get a more efficient surface layered sorbents. If we compare the initial plots of breakthrough curves, we see that in case of surface layered sorbents, we see less content of carbon, and the passage of analytes happens when the volume is 1.5 times higher if we consider a similar situation with volume porous sorbents. The application of surface layered sorbents allows us to increase the speed of concentration of analytes with the rise of extraction gas flow. When we compare, so on the side you see the dependencies of slip volume from passage rate when we used the column filled with activated carbon based on furfural. And high affinity of such sorbents to analytes allowed us to use a more simple scheme of one-stage thermal desorption. After the passage of certain volume of the extraction gas, the desorption column was placed to a thermal desorber, and it was heated. After that, we introduced the needle to gas chromatographer. Then we shifted the valve to position 2. And analytes were shifted from sorption to capillary columns. And the characteristics of the scheme are given here on the slide. The detection margin corresponds to the volume of extraction gas passed through the column. And at that, increasing these volumes up until slip volume, we can reduce the detection margin. And this scheme allows us to define low alcohols and ketones at the level much slower than maximum permissible concentration. So analytical opportunities of generation of standard gas mixtures and VOCs on block and composition matrices in full extraction regime was started before. However, the opportunity to generate standard gas mixtures in full and partial extraction regimes and the application of granulated solvents was not discussed. Full extraction mode suits better for small polarity coefficient, for small polarity modes. And here you see the dependencies of concentrations of analytes on the consumption of phases. In low correlation area, the dependencies are linear, and we see the full extraction mode. When this correlation rises, full extraction shifts to partial extraction. In low concentrations area, as you see on image 6, the concentration of analytes in gas phase grows proportionally to the increase of their concentration in the aqueous solution. And for substances with mid-polarity, we should consider partial extraction regime, and it allows to get information on the distribution coefficients. And for that, it's enough to find the correlation of concentrations of components in the gas phase at different correlations of flows of the exchanging phases. And using this equation, we get the fourth equation. Then we calculate the distribution coefficient for the test components chosen. You see it in the table, and you see the correlation with the literature data here. Compared to uninterrupted option of chromatomembrane gas extraction, discrete extraction is a more simple one. It is carried out on composition matrices that are saturated with target elements. The application of granulated solvents allows to increase the sorption-activated material content up until 30–40% compared to block matrices. And at that, the presence of sorption material does not influence the initial concentration of the components in the gas phase, and it specifies the value of the buffer effect that emerges in the increase of the gas phase at stable concentration. And on this slide, you see the dependencies of initial concentrations of gas phase components from their concentration in aqueous solution. The application of granulated composition solvents can be done for compounds on well-sorbed aqueous solutions. And here you see the generalized characteristics for standard gas mixtures. And we've calculated relevant errors for all schemes that do not exceed 9%. And on the slide you see the conclusions. Thank you very much. Thank you very much, Aleksandra. Do I have any questions to the candidate for the degree? Okay, no questions, and I have one. You used one-step and two-step thermal desorption. In what cases did you choose each of them? The choice of the scheme depends on those analytes that we want to define, because the one-step thermal desorption scheme, if we apply a carbon chloroplast option can be applied for several substances. Okay, now we're going to listen to the reviews. I have an offer to answer after each review. Do you agree with that? Okay. We got no external reviews. As all the reviews were already published on the St. Petersburg State University website, I offered to read out the basic points, the comments, the questions to the candidate for the degree. Okay. Now I would like to give the floor to Professor Zinkevich. So please, Professor, you have the floor. Distinguished Chairwoman, thank you. I believe there's no need to introduce myself once again. Yes, certainly I've introduced you already. Okay. First of all, I would like to say that the presentation fully corresponds to the text of the thesis. And the main thing to the published works, I believe that's needed. Therefore, I wanted to start with that. Indeed, my review was already submitted and published. There were 4 publications, and that's quite enough to introduce a topic and to take it for the defense. 1 in analytics and control. I believe that's the most important thing, because the readers could learn about the major provisions of the work, the goal of the work. Yes, before that, I wanted to mention that the same wordings can be used to illustrate both goal of the work and the scientific novelty and practical value of it. And to my mind, that's the demonstration of harmonious work, and I believe that's an advantage. So we needed to detect the regularities and analytical opportunities of chromatomembrane gas extraction as applied to 2 goals: the detection of microconcentrations of VOCs in aqueous solutions and the generation of standard gas mixtures. So both issues were considered, both problems were resolved. Thus, this wording reflects the list of goals, and therefore we should mention that the thesis corresponds to the specialization requirements. And then I mentioned the key elements of the scientific novelty. I won't read them out. Then as for the practical value of work, it fully corresponds with the goal, and the problems resolved. The relevance of the work is demonstrated by the opportunity to improve the operations of sample preparation. Then we have author's description of methodology and study methods, and it corresponds with the experimental part, and it goes without question that the credibility of the results is quite high. So these are the points that I should have read according to the requirements. As for the discoveries, there's a huge volume of information described in the work. Therefore, in each chapter, the author gives short conclusions. And these short fragments do not duplicate the final conclusion. They are more particular, but they create a very good impression on the work overall, and I wanted to mention that. The text is very accurate, has no misprints. As for the questions, Aleksandra learned about the questions before, so she had an opportunity to answer them, and I didn't have any additional questions. And in conclusion, I would like to say, well, I believe I should read it out. Based on the above mentioned, I believe that the thesis by Aleksandra Petrunina, titled Chromatomembrane Gas Extraction in the Processes of Concentration of Volatile Organic Compounds from Aqueous Solutions and Generation of Standard Gas Mixtures, meets the requirements of the order as of September the 1st, 2016, number 6821/1 on the procedure of granting academic degrees at St. Petersburg State University, and the candidate for the degree deserves the academic degree of the candidate of sciences in chemistry in specialization 020002, analytical chemistry, and Article 11 of the above-mentioned order is not violated. Thank you. Thank you, Igor. Do you have anything to answer? Yes, I thank Professor for the review. Okay. Now I give the floor to our next member of the board, Vladimir Povarov, St. Petersburg Mining University, the Doctor of Chemistry. Being a user of absorption methods, I do not question the relevance of the study, as well as practical value that is described in the thesis quite well, as well as in the publication works. As for the publications, I would like to join in and to support my colleague. And that the publications give full results and there are no questions about them. But for a very long period, I wanted to ask people who work in this area, I wanted to ask these two questions. One of them is a provocative one, and another one is something that I long wanted to ask. So I had two comments. The first one. What about the verification of this method on natural mixtures, on natural objects, or even on model objects? When I'm interested to learn about a specific situation, for example, when in the mixture we have some additive that is able to absorb on your sorbents, certainly there is this competition absorption, and it may lead to certain unexpected results. So that's the first question. And the second question, well, I know that it's a provocative one, but still. What control method of the content, except for those given in the thesis, could be provided for the proposed generation method? So why do I see it as a provocative question? When you get a balance with the content that you know, there are no control methods on offer except for multiple use and verification or in practice that it actually works. But maybe you have certain ideas to share. No, that no one voiced before. But overall, it does not, and these questions do not influence the credibility of the results and the relevance of the study. And I believe that thesis fully meets the formal requirements that are given to such dissertations in analytical chemistry field, and I believe that the author deserves the award of the degree. Thank you. Alexandra, do you have an answer? Yes, thank you very much for the questions. As for the first question about the analysis of real objects, in previous studies, the analysis was carried out of water samples from Yaus and Neva River and from the Gulf of Finland. Therefore, we can believe that chromatomembrane gas extraction and chromatomembrane cells can be used for the analysis of rather pure waters, for example, purified sewage waters and drinking water. And it's hard to assess the influence. There was no goal to assess the influence of admixtures, but we can say that humic acids influence the process and their content can be assessed visually. And if we talk about high concentration of inorganic salts, then we can say that we'll have salting out processes and distribution coefficient will change for VOCs. And this will have a negative impact. Are you satisfied with the answer? Yes, that's the first answer. Well, yes, I'm quite positive about the answer. Yes, I like the answer. No, the second answer. Then the permanent content in standard gas mixtures is provided by the continuity of coefficients of interface distribution of analytes of the components, and activated carbon content does not influence whatsoever. If we talk about the concentration of analytes in the generated gas mixture, because the distribution coefficient does not influence the presence of sorption material, and as it does not influence the characteristics of water and gas phase, we can say that chromatomembrane cells are applied for the generation of standard gas mixtures directly before the analysis, so they should not be stored. Vladimir, do you like the answer? Yes, I do. Okay. Now I give the floor to Professor of the Analytical Chemistry Department of the Moscow State University, Grigory Tsizin. So, please, Grigory, you have the floor. Thank you, Anna. As the previous members of the board, I provided a full review. I submitted it, and I'll be pleased to say a few words about the thesis. First of all, I'll give you the remarks that I should have given and about the work overall. First of all, I would like to say that I like the work a lot, as all the works of this scientific specialization. That's not the first analytical chemistry work that I'm providing reviews for. The work is quite relevant. The detection of VOCs in aqueous objects, in aqueous medium. The existing solutions can be criticized, but as a result of metrological tests, those are not quite high, and any attempts to improve these metrological characteristics should be welcome. Therefore, the relevance is not questioned at all. As for key points that I wanted to mention, and the main thing that I wanted to mention is that Aleksandra managed to shift to a different solvent class, and these solvents can be used in chromatomembrane extraction as part of the cell. So that's an interesting point, and I believe that this idea was implemented in the new mode of detection of VOCs, and also it can be used for the generation of standard gas mixtures, and I believe this point is of particular importance. Block polymer solvents based on fluoroplast were not replaced, but rather, you see, they were compared with surface layer solvents, and in this case, mass exchange changes, and we need to study it carefully, and that's what the author actually did. And this mode also has certain advantages that the author has demonstrated. And I believe this is a demonstration of the scientific novelty. As for the credibility, it's not questioned as well. The credibility of results. And there are several comments that I wanted to read out shortly. There's a comment on literature volume. I read it just because quite frequently in the works of your department on a different topic, I wanted to comment on that as well, because I believe that in a literature review you should have a wider description of the existing methods of VOCs detection methods. You are not talking about lidars, gas sensors, and so on. You are just going to the narrow field, to this narrow field at once, without some general descriptions. But that's negligible, you know. Next comment is about the style. Some parts of work are given in a style of monography, in style of monograph, and it's unclear where these parts of the work finish, parts that were done before or after, and where do we see the start of the experimental component. then we managed to sort it out, but certainly it would be better to describe it in fuller detail initially, from the very beginning. The same comment that was already mentioned, you offer the new mode of VOCs detection. Are those application margins? What about them? What objects can be analyzed? Because carbon sorbents, they're not selective at all. They can absorb a lot of things. And don't give the answer to this question because I've already heard it. I just wanted to emphasize that this work would be even better if there were certain attempts to describe it. And basically that's it. There were some misprints, but that's not important. I won't read this mandatory part. I'll rather say that, to my mind, Aleksandra fully deserves the degree of the candidate of sciences in chemistry and analytical chemistry. Thank you very much, Grigory. Aleksandra, do you have an answer for that? Yes? Yes, I fully agree with the comments. Yes, fully agree with the comments. Okay, thank you. I'll read certain fragments from the review of Professor Sidorov. From the Polish University. The main ideas are as follows. The author managed to move forward in the resolution of the above-mentioned problems, the microconcentration detection of the VOCs, and also she described the novel principles of the creation of gas mixtures. Previously, it was demonstrated that chromatomembrane gas extraction mode is significantly more advanced than traditional similar methods. However, the proof of advantages was quite illustrative, and it did not cover metrological aspects and analytical aspects of this approach. The provisions for the defense, the conclusions are supported. The logic of work is rather strict as for scientific novelty, regardless of previous works that studied regularities of chromatomembrane gas extraction as applied to chemical analytical and chemical metrological goals. The scientific novelty of this work is not questioned. With this, the author detected the regularities, found the optimal conditions, and these conditions are listed in the review, and chromatomembrane gas extraction of VOCs from aqueous solutions in combination with gas absorption concentration is described, and also the advantage of surface-layered solvents is described in the work as well. For the first time, the author implemented uninterrupted and discrete option of gas extraction on granulated carriers and granulated composition carbon chloroplast solvents, and there is this practical value of work. The author proved the opportunity of multiple increase of volume with the use of discrete option of chromatomembrane mass exchange process in the system liquid, gas, and hard body on surface-layered solvents. This was mentioned in the results of the study, that 4 articles were published, and overall the thesis makes a very good impression. However, there are certain questions and comments. First, in the work, the author devised methods to define compounds that refer to different classes of organic substances: spirits, ketones, esters and ethers, aromatic hydrocarbons, ether, but there are no such components as aliphatic hydrocarbons described. Second point, currently there are are rather convenient devices to detect VOCs in aqueous solutions in order to provide gas chromatography detection after thermal desorption in the injector of gas chromatographer. In the work, the authors studied rather rare commercial chromatomembrane cells. Will they be durable, and how can you use them? For what objects? Third point. In Table 8, you provide the data on retention of phenol on 9 different solvents. However, the information that confirms the opportunity to detect it using the method provided by the author is something that will lack. The same is true for standard gas mixtures with set phenol concentration. How can you explain that? So these are the questions. And as for the comments, they do not compromise the overall high mark of this work, and the thesis of Aleksandra Petrunina, titled Chromatomembrane Gas Extraction in the Processes of Concentration of VOCs from Aqueous Solutions and the Generation of Standard Gas Mixtures, corresponds to the requirements of the order of St. Petersburg State University, and candidate for the degree Aleksandra Petrunina deserves the academic degree of the candidate of Sciences in Chemistry in Specialisation 0200002 Analytical Chemistry, and Article 11 of the above-mentioned order is not violated. So, Alexandra, your answers? Yes. As for the absence of aliphatic hydrocarbons in substances, that's explained by the fact that they have a rather low distribution coefficient, smaller than 1. They are polysoluble in water, and they are easily extracted using hard phase or liquid extraction. If we talk about the generation of standard gas mixtures based on their low distribution coefficients, we would get rather small volume of the generated mixture, and that's not expedient. As for the definition of real objects, we've already answered this question, and we can add that chromatomembrane cells are multiple-use cells, and when defining rather pure objects, we can use several dozens of definitions. As for phenol, in the work I demonstrated that thermal desorption of phenol is impossible from the activated carbon on furfural. Therefore, it's expedient to combine furfural with liquid rather than gas chromatography, and extraction there is carried out in organic solvent. If we talk about the generation of standard mixtures, then phenol is rather a semi-volatile compound, but we were considering highly volatile compounds. That's it. That's it. Okay, thank you. Okay, and let me read my review on the thesis. As it was mentioned several times, the work tries to answer two important questions within the framework of chromatomembrane gas extraction. She tries to resolve the problem of microconcentration of VOCs, detection, and she devised the principle of the creation of standard gas mixtures. The work, sure enough, is aimed to resolve the most relevant problems, and this relevance is explained by the need for sanitary and hygiene control. If we talk about drinking water, and the thesis is based on the classical principle, and I would like to make a comment on the literature review. It's quite fundamental, and it allowed the author to sort out the goal to find regularity, analytical and metrological Options of chromatomembrane gas extraction as regards to micro-concentration of VOC's detection and the generation of standard gas mixtures of those analyzed for gas analysis. And the author chose the material for chromatomembrane matrix, high adhesion, for example, and during the resolution of the problem she takes into account that gas chromatography analysis is carried out, and she preferred thermal desorption rather than the desorption with organic solvents, and this allows to reduce detection margins. It secures multiple use of sorption tubes, and we don't use toxic solvents that could be sources of additional admixtures. In the process of work, the author makes a series of good observations. The previously applied volume porous solvents limited the opportunities of chromatomembrane option of gas extraction, and it was shown that the use of bulk composition matrices allows to increase the volume of generated gas mixture. Yet another important point, the advantage of surface layered solvents shows at a high pace of gas phase transfer, while the major contribution was done by external diffusion mass transfer. The devised analysis scheme that is based on chromatomembrane option and thermal desorption of analytes with carbon fluoroplast solvents, take into account capillary column and flame detection method. So that all allowed to get a synergy effect. It allowed to reduce the concentration time, and thus getting a result is something that was made possible if we consider concentrations lower than minimum permissible concentrations, and this allows to carry out background monitoring of analytes. Yet another important result of this work that was mentioned today is as follows. She detected the opportunities to use the equilibrium saturation mode and full extraction of target components in the implementation of uninterrupted gas extraction for the generation of standard gas mixtures with previously set concentrations of analytes at the level of ppm. Previously to this, and liquid solvents were used, well, organic solvents that were quite volatile. And as for the approach that was offered by our author, it allows to get gas mixtures that are saturated with water vapor, which is very important when we analyze atmospheric air and air that is breathed out. That all secures scientific novelty and the value of the work, and the author also mentioned single-step thermal desorption for spirits and ketones, and this was possible because these solvents were studied well and they show good affinity to the analytes, and double-step method was shown for aromatic and chlorinated hydrocarbons. As for the publications that were mentioned as well, and as for the testing of the results, but still I have certain questions on the text. You say that the more polar the analyte is, the lower the temperature of gas extraction should be due to the loss of analyte in the formed condensate. What if the extracted mixture of low molecular analytes is different in polarity? What's the strategy here? Second question. What's the reproducibility of sorption characteristics, the distribution of pores, a specific surface, specific pore volume? If we talk about composition, carbon, fluoroplast solvents, how can we assess the influence of the temperature on the efficiency of chromatomembrane gas extraction in combination with PATP? The full extraction mode, and that, by the way, is described in the thesis, allows to avoid thermostat use, but it requires exact regulation of flows between liquid and gas phases. How do you achieve that? In conclusion, there's one wording saying that advantage is confirmed for chromatomembrane gas extraction compared with traditional similar options. The question is it confirmed or is it established? And second question, did you carry out the analysis of real samples using standard gas mixtures? And not just for a ritual, but being completely sure about that, I want to say that these questions do not compromise the most positive impression on this thesis. The thesis by Aleksandra Petrunina meets the requirements of the order of the procedure of granting academic degrees at St. Petersburg State University. It meets all the necessary requirements. It uses all the experimental methodologies, and it contains a very good solution to the analytical goal. It defines regularities and defines the conditions for chromatomembrane gas extraction process for VOCs. And she used the granulated coal-processed solvents as an example. And also the author devised the basics for chromatomembrane gas extraction mixtures. So, as I've already mentioned, the thesis corresponds to the major requirements of the orders of St. Petersburg State University. And the candidate for the degree, Aleksandra Petrunina, deserves the academic degree of the candidate of sciences in chemistry in specialization 020002 analytic chemistry. And as the previous colleagues, I would like to mention that Article 11 of the above-mentioned order is not violated. That's it, what I wanted to say. Your answers. Thank you very much. If the low molecular analyte mixture is different in polarity, then chromatomembrane gas extraction will be limited by the most polar analyte, and you should choose it so that the loss of most polar analyte would be insignificant. That's the first question. A second question. Previously it was mentioned that pore distribution in size, in specific surface and in specific volume of this option active material do not depend on PTFE carrier. The retention volumes increase proportional to the increase of the share of sorption active material on composition solvent. In case of chromatomembrane gas extraction with PATP combination in equilibrium saturation regime, when the coefficient of distribution is higher than the correlation of exchanging phases, the rise of temperature by several dozens of degrees goes together with the drop of coefficient of analyte distribution and with the rise of their concentration in extravagant gas. In case of full extraction, the rise of temperature does not influence the concentration of analytes in gas extravagant, and adsorption concentration in all cases is carried out at room temperature in full extraction mode. And as the regime of full extraction allows us not to use thermostat, we need to have very specific regulation for exchanging phases. The flow of liquid phase was tested by the regulator of gas consumption, and these regulators were included into electron formation of gas flows that were used in the work. As for the wording, previously it was mentioned that chromatomembrane gas extraction is better than traditional similar methods, and the use of composition surface layered solvents was seen as better than traditional volume porous sorbents, and we confirmed that the combination of chromatomembrane gas extraction with surface porous solvent with surface layered solvents allows to improve the process. As for analysis of real samples, it was not carried out because we were based on water objects mainly. That's it. Thank you. We continue our session. And I want to ask colleagues who are not all the members of the board, maybe there are colleagues who are willing to ask a question. No questions. Okay. Do we have any external reviews? No. Okay. And then I would like to give the floor to the thesis supervisor, Professor of St. Petersburg State University, Oleg Rodnikov. So please, Oleg, you have the floor. Thank you so much, Anna. Certainly, I won't compliment the work because it was already mentioned. Colleagues have already mentioned the content of work. And I wanted to characterize, to give a characteristic to Aleksandra. She has made a professional choice quite early, and she came to the analytical chemistry department when she was on the second year, her second year. She defended the diploma work quite well. She joined a PhD course. She wrote the qualification work on time. And she got an A mark for it. And at that, I can say that during her PhD studies, she also worked as an engineer on our department. And during her study, I mentioned that she's very oriented at getting the result. The author showed that she has very good skills of working with scientific literature, and she demonstrated that she's a really good thinker and experimental scientist who can be quite critical about the results. As for Aleksandra's articles, they were already mentioned by the colleagues, and I wanted to add that the studies were supported by 2 projects of the Russian Foundation for Basic Research, and she was one of the key scientists who carried out these works. So I believe that Aleksandra can be characterized as an established expert who is able to independently work on trivial problems. Therefore, I'm sure that she deserves the award of the academic degree with the Candidate of Sciences in Analytical Chemistry. Thank you. Thank you, Oleg. As we're holding our session with participants who joined us remotely, I have the following question. Do the members of the board or anyone present have any questions? Maybe the candidate for the degree has a question on the procedure of the defense. Aleksandra, I had this question when I read the thesis, but I decided not to ask it, but now I was provoked by the chairwoman and by your answers. But just I wanted to specify, when we talk about the polarity one analyte is more polar than another one. There was a Katrinsky review 10 years ago. For organic compounds, we know 170 polarity criteria. Sometimes they contradict each other. Could you please tell me what definition do you want to use when you are talking about the polarity of analytes? Well, frankly, these conclusions are based on the values of distribution coefficient, because that's the key parameter when choosing the generation schemes. Okay, thank you indeed. That's one of these 170 parameters. Okay, Igor, thank you. Alexandra, thank you. Any other questions? No questions. Okay. Distinguished colleagues, we can shift to the discussion if there are any speakers willing to deliver their reviews. So, please, Vladimir, please. I can but add to what I missed in my review, that this work is quite a trendy one. If we consider the contemporary analytical chemistry processes, because indeed we are talking about automation, about novel automation of preparation for chromatography analysis. And as our experience has shown, automation today in analytical chemistry, well, it's part of success, half of success, because it provides for the speed of submission of analytical information, and it provides for reliability of control procedures. Therefore, though I did not mention it in my review, that's an important point that we should not underestimate. That's really a pity that sometimes we hear that such devices are hard to access. Well, maybe the representatives of the school, maybe they will finally make the system more popular, and ordinary users will be able to use the systems. Maybe they will be able to answer the questions that we ask today. Grigory, any questions? No? But I wanted to ask, why didn't you give me water? Yes, okay. We'll think about options. Well, they say in remote access you have some water for you. Okay, distinguished colleagues. Any other questions? Okay, none. Therefore, we stop our discussion, and it's 13 minutes past 3, and we are shifting to the vote. And we don't take other questions. Distinguished colleagues, we have the following option. Before the voting procedure, we can organize a short closed discussion in order to consider the results of the defense. And this session will not be broadcast. Please tell me, do we need to hold such a meeting? Yes, call the members of the board to answer the question. I believe there is no need for that. Okay. Yes, I agree. No need for that. Yes, I join in. And Grigory supports this idea. Okay. Let me remind you that the decision of the Dissertation Board on conferring the academic degree on specialization Analytical Chemistry is valid, providing 2/3 of, provided more than half of the board members, but not fewer than 3 people voted in favor. That's in conformity with Section 23 of the order, and I'll ask everyone. Igor Sienkiewicz. Professor Sienkiewicz, please turn on your microphone. What's your opinion? I believe that Aleksandra deserves the academic degree of Sciences. Okay. Vladimir Povarov, what's your opinion? I believe that Aleksandra deserves the academic degree. Okay. Okay, now it's important to listen to the opinion of Grigory Tsizin. Yes, I've already mentioned that in my review, that Aleksandra deserves the academic degree of the candidate of Sciences in Chemistry. Okay, thank you. And being a chairperson, I would also like to say that certainly Aleksandra Petrunina deserves the academic degree of the candidate of Sciences in Chemistry in Specialisation 020002 Analytical Chemistry. Thus, distinguished colleagues, we have to calculate the votes. And out of the 4 participants who took part in the board session, 4 members of the board voted in favor, no one voted against, and no one abstained from the vote. Thus, we award the academic degree of the candidate of Sciences in Chemistry to Ms. Petrunina in Specialisation 020002 Analytical Chemistry. Distinguished colleagues, due to the fact that our session is held remotely, I would like to ask if the members of the board, or maybe the candidate, have any comments on the procedure or any questions. Okay, no questions. So I give the floor for the finalizing remarks to our candidate for the degree, whom we congratulate today, and we wish Aleksandra that this start will be a real start in her academic life, and we wish her further success. Thank you very much. I would like to thank all the board members for this friendly atmosphere, and certainly that's the first experience of such a procedure for me, and I want to mention that for all the members of the board, that's also the first experience of my defense, and I believe that all other board sessions on analytical chemistry will continue our experience, and I would like to express my gratitude, heartfelt gratitude to my academic supervisor who supported me and helped me, and I would like to thank my husband for the support. Okay, thank you, Aleksandra. I believe that this experience that you gained today will help you to continue and to proceed. Distinguished colleagues, I therefore close the session, and I thank all the participants, and I can be asked to turn off the broadcast.